In this video we're going to do a follow-up to converting a Disco 2 LT230 to a Defender. Well, I started on this project a few weeks ago, but the parts only just came in yesterday, the bearings from Ashcroft, so I thought I'd jump onto it. There are a few little things that you maybe should need to know. The gearbox is in question. It's called an LT230 SE. Now, this is where it gets a bit bizarre because there was a changeover in 2002. These boxes are very handy to have because they've got a lot more modern bits and pieces in them. If you can see inside, this is a 1.2, so this is going on to a V8, and the teeth are much finer cut, which is nice. You know, that's like Puma type style. Also, I don't know if I can show you on here. Maybe I can. You see the teeth here on these gears? Well, they're very thin, and that means if you're going to do an Ashcroft conversion onto a change of ratio, they require the thin teeth for this hub here. Now it is a bit difficult to explain, and I'll do it again when I do another conversion, if I do another one. But if you want to change this high ratio gear here, you've got to have a corresponding hub to match. Now these hubs are about 140 odd quid each, so if you can get a second-hand Disco 2 box for like $100 or something like that, well, it was worth it just for that bit. Now the pitfalls is with Disco 2s, as you can see here. Probably not. I have to come far back because I've got no room. No speedo drive on the output. Not a problem for these boys because they're going to put a GPS speedo in. Other thing, the nose piece here is completely different. Alright, you can notice that this was the model without the diff lock in, but they didn't just put a blanking plate on, they didn't even bother drilling it out or tapping it, and likewise the shaft that goes through here isn't even machined. JP wanted to do it, and I said, well, it's not really worth it. It's not really worth it because that bit really doesn't really go wrong. So if we've got an old Defender one, we can use that. What else? Now, reading the book about this LT230 SE, and if you get the later book, like 2003, I think it's almost the very last book, it actually tells us what we wanted to know about setting up the preload on here and the preload on this intermediate gear here. It's very important. Now in the vise here I've set up our funky gizmo for testing out the different size steel bushings, because we don't put the collapsible sleeve in like this because they're awful, they're terrible things. They don't collapse square, so we measure up and we put a steel tube in just like Land Rover did. Now in this instance here, on this one here, we fitted new bearings and used the original sleeve, steel sleeve, because I put steel sleeves in like 2003. Put it in and we set it onto the little test bench that we've got here. It's just a pin supported by a shaft with a hole in it, replicating the transfer case height here, and it was beautiful. It was beautiful, so I just put it back in. Now on here, on this example, I've got here, this is a 1.4 transfer case out with 300 TDI, the gears. Now I'm using used bearings because they'd just been replaced a little while ago with the Timken ones, but they're worn, they're settled in, and the largest shim that we've got, like the largest one of these steel tubes, is just a bit too tight. It's supposed to have about 1 Newton metre of turn on there, and that's just a little bit too tight. Once you've worked out what it should be, like we had a bit of string and pull in it, it's kind of easy, you get to feel it. But once you've got that set, then you can put it in to your LT230, and this is where the clever bit comes in. We always struggle trying to get the shims for here. Now a lot of people change the intermediate gear, the input gear, the main shaft gear, they change that when the splines have gone. And the thing is that when you put new bearings in and things like this, you have to really change the shimming. You might have to, you never know. But generally speaking, they're okay. But in this instance, it was interesting because the original shim in this box, because remember this is Disco 2 box, an early one, well, pre-2003. In the 2003 manual, it states, put this gear in, which has already been preset with your steel bush, and then get one of these. Well, they've got more fancy to them, more sophisticated, but I've got a little 1/4" drive, what does it call them, balance beam or something like that. It was only $10, wasn't much. But the nice thing is, it's got a scale in inch pounds and Newton meters, and this is what we want. So that's a piece of shaft off a front drive shaft, 10 spline, no good to man the beast because I cut it up, and then we welded a socket on the end, so you've got a 1/2 inch drive. Pop that in there, and what you're looking for is 2 Newton meters of turn, and that is exactly 2 Newton meters. So I had to adjust the shim a little bit in here, and that's so easy. So you're dragging on here, and you're dragging here as well. This is brilliant. You know, it makes life so much easier. Better than putting bits of string round and calculating this and tightening this down. Because if you put the crush sleeve in, this thing here, if you put that in, you can over crush it, put too much tension on here, and this will put all the settings out here. Do you get it? I don't. Anyway, so that's one thing out of the way. Second thing you must know, well, you don't must know it, but it's kind of interesting to know. We're fitting me and you, we're fitting an ATB, Ashcroft's ATB, and the first one I did, I had problems with it. I'll admit it, and I've talked to Dave about it. He didn't know what the problem was, but JP and I, we took this down to the shop, and it wasn't the ATB that was a problem. We'd bought a 300M shaft to go in here. This thing, now you can just see it here. Alright, now this is the original old shaft. What's wrong? Well, they wanted a heavy duty shaft, and that 300M is supposed to be a super duper one. Now this is how it usually fits. Like that. However, on this one, even though JP's got a special micrometer that can measure inside depths of splines and screw threads and things like this, you measured the depth of this one and compared it to that one, it was almost the same. Thousandths of an inch different, thousandths, tenth of thousandth of an inch. Measure the outside diameter, same. But it wouldn't go on. Well, what would happen was, you'd get it halfway, but you'd get it in the spline, and then it would jam. Now, I didn't know this the first time I did this, and I had the gearbox sort of inverted, and I was putting the nose on because I wanted to find the height for this shim that goes behind this bearing here that goes sort of to the other end of here. So, you invariably have to lift up that unit with a pry bar to look at the measurement before and after and calculate the shim, correct? Not in this case. The bloody thing had jammed in, so that meant me taking the whole bloody transfer box apart to get it out, because there's no way to pry it from here. It would stuck right on this lip. So this first gear, this low range gear, had stuck here. What a pig of a job that was. So, knowing that, when we got that shaft there, we thought we'd try it in this ATB, and again, it stuck. Now Dave said he's changing the manufacturers of these shafts, but that, well, I didn't feel happy with that. So anyway, what we did, it's crazy, isn't it? We got a very thin Dremel and started to cut the threads a little, cut the splines a little bit. Now once we did that, we got one of these gears that goes into your differential. This is an old one, but put some grinding paste on it and tapped it on like that. Tapped it off, turned it around, tap it on, tap it on, tap it off. You get the picture. For over an hour and a half. Then it fits lovely. Now this is probably knackered now because it's a bit too big, but we keep this one just in case we have an ATB, a 300M shaft to do again. But the grinding paste worked great, and now we can quite comfortably drop that on and we won't have a problem. It'll be just, that one there fits like this now. So what was the problem? Well, obviously we haven't got microscopes and stuff like that, but JP came to understand that the splines are not even, which is strange because splines are, they can be rolled, like two rollers with opposing dies on, like that type of thing. They can be rolled on, or they can be broached on with a machine that goes like that. It should be pretty much straightforward. But we couldn't work it out, and it's only on those 300M shafts. So anyway, just pay attention to that if you want to put one in. All right, check the splines. The ATB was great. There's no problem with that at all, but it was just the spline. So what else have we got to do? Well, I'm just going to go down to JP. How am I going to go down to? Do I need to go down? We've got that one right. We've got that one right. This one in here. This steel bush in here is just a bit too tight. It is Friday, so I might just nip down to get another tube made, but about tenth of a millimetre longer, and then we can work out how much there is. I don't know. Interestingly enough, I just put that down. That is the difference in the heights. This is how much it's got to crush. I've put my thumb along the bottom block. So that's how much it's got to crush. It isn't much. Anyway, so that's what we're up against. I just thought I'd tell you what the progression is. Next step. Now I'm happy with this here, this 2 Newton meters on here. I can box this up, take out the intermediate again, because I haven't put the O-rings in yet, you see. And then we can start to work out the height of the ATB. So anyway, I hope that was a little bit of more insight to you. I will show you it when it gets finished. We'll put it on the bench, but everything's, you know, really nice. No problems at all. See you later.